Okay, hi, assalamualaikum and greetings to all of you. So today I will continue spherical coordinates in triple integral coordinates. So I would like to draw sphere first to understand the mechanism of the integration. So see, I choose okay. So let's say I have Z, X and Y. Then I have then okay, I have a sphere. So three things. Let's say I have a point P here, P, that is function of rho, phi and theta. Okay, so the angle from Z axis clockwise is called phi. Okay, so phi is from Z axis clockwise, and the minimum angle is 0 and the maximum angle is pi. Okay, then we have theta. Theta should be from positive x. We call them polar axis. We call them theta. Okay, theta. So your theta from polar axis or from positive x-axis, anti-clockwise direction. Anti-clockwise direction. Okay. So the theta is not necessary from 0, can be from, let's say we have two circles, so this theta, but it is counted from the polar axis, from the pole, which is from the origin. So let's say I want this bound, it is for this region, so I have to draw two things. One, the first radius, and this is the second one. So the radius is from this point to this point. Okay, but the maximum will be, the maximum of theta should be 2 pi. Okay, next about the r. So the rho, actually rho is actually about the radius. Phi, the angle from Z axis. Theta is the direction from X axis and it is anti-clockwise direction. This is clockwise. Okay, so to find this rho, so actually from the center to the surface will be the rho. So rho, so this will be the r. Okay, so we can take out the rectangle. So let's say this is the phi from positive Z axis, and then we have Z here, this is Z axis, then this is R and this is phi. So from here, sine phi is R over P, rho, sorry, so R is rho sine phi. So cos phi is Z over row adjacent over hypotenuse. Okay, so Z is equals to rho cos phi. So then tangent phi will be R over Z. So phi will be tangent R over Z. Okay. Okay, remember, rho is regarding radius, phi is regarding positive Z axis, theta start from positive X axis, and it is anti-clockwise. For phi, it is clockwise. Okay. So you know, R is rho sine phi, X is R cos theta from cylindrical coordinate. So R is rho sine phi. So the X will be sine phi cos theta in spherical coordinate. Your Y will be R sine theta from cylindrical in spherical coordinate. Rho sine phi sine theta. Okay. Your Z is rho cos phi. So in sphere, x squared plus y squared plus z squared will be rho squared. Okay, you can substitute the x, y and z, you will get the rho squared. So rho is the radius of the sphere. Radius of sphere. For cone, cylinder, and circle, we use R. Okay. Okay. Next. So we go to the slide. See your slide. Make sure you print your slide. We go question 1. Slide number 37. Question 1. Okay. Triple integral. They ask you to evaluate the integral using the spherical coordinates, that is triple integral G cos x squared plus y squared plus z squared cube. dv bounded by z equals to square root 1 minus x squared minus y squared and z equals to 0. So from this you can square both sides. Remember, this is plus, which means you just consider the upper half circle or upper half sphere. So also you get z squared equals to 1 minus squared minus y squared. So if you rearrange, you will get x squared plus y squared plus z squared. So this is nothing but sphere radius 1, but we just consider upper half sphere. Okay, so this is hemisphere. So if we draw 3D, let's see, I have radius 1, so 1 and here 1. Okay, so the bottom part, this is the bottom part. Another one is, so if you extend this, so here also 1, so is z x y 1, so here and here, I think. Okay, then you just merge it. Okay, you merge all the points, you get hemisphere. Okay, So okay, now we have to find the limit. Remember, you have three things: theta, phi, and rho. We have to find the three limits for spherical coordinate. Okay, why? Because this dv is represent as your dv is rho square sine phi d phi d rho d phi d theta. Remember, for spherical coordinates, the integral is rho squared sine phi d rho d phi d theta. So you need these limits. Okay, for cylindrical coordinate, it's just z r d theta, r dz dr d theta. This is for cylinder, okay, cylindrical coordinates. Okay, so this is the element of the integration. Okay. So the limit of theta for this hemisphere will be, so if you see, theta is in xy plane, start from here and up here. It's a circle, right? It's a circle. If you plot yx, it is just a circle with radius 1. So the angle should be from positive x-axis anti-clockwise. So the limit is from 0 to 2 pi. Then how about the phi? The phi must be from positive z-axis, right? Okay, here. Is it? No, should be from here to here. Okay. Okay, the whole surface from the z-axis, positive z-axis. So the angle for phi from 0 to pi over 2. Okay. Then rho is radius 0 to 1, easy. Okay, so now we have all the informations. Remember the theta angle of xy plane. So your xy plane is a circle, so that's why 0 to 2 pi. The phi is angle from z axis, positive z to negative z, but here we just stop here because we just consider positive part, which is hemisphere, half of sphere. Then the rho is radius of the sphere. Okay, refers to the hemisphere also. Okay, so z equals to negative 1 minus x squared minus y squared. No need to integrate, okay, because they did not ask. Okay. So triple integral g will be cos, so x squared plus y squared plus z squared is nothing but rho squared. dv will be will be cos rho squared, this is rho squared cube square root. Okay, and we have to add rho squared as mentioned here. Replace the dv, sine phi d rho d phi d theta. Okay, you don't mix up with these two. One is phi, one is rho. Phi refer to z-axis, theta refer to xy plane. Okay, so your d phi refer to the inner integral. So your phi is from 0 to 1, your radius. Then your phi is the second middle integral. Phi is from 0 to pi over 2, the lower limit and upper limit. And then we have theta from 0 to 2 pi. Okay. So you can cancel out this square root. You will left cos rho cube rho squared sine phi d rho d phi d theta 0 to 2 pi, 0 to pi over 2, and 0 to 1. Okay, so if you solve this, okay, if you solve this, you will get 0.5614. Check. Please check. Okay. So remember, we have parentheses here. You put your rho square in front so that you are not confusing what you are doing. Okay. Okay. Next, 1b. Integrate, also triple integral. Use spherical coordinates to evaluate the integral g e to the power of squared plus y squared plus z squared all to the power of 3 dv. Okay, where g is a solid bounded by z equals to square root 1 minus x squared minus y squared, and z is equals to square root x squared plus y squared. Okay. Okay. Solid bounded by. So z is equals to z squared equals to 1 minus x squared minus y squared. So if you rearrange, you will get x squared plus y squared plus z squared equals to 1. So this is just a sphere with radius 1. Okay. So this is, the question is positive, so it is just a hemisphere. Hemisphere with radius 1. Rho 1. Okay. Then we have z equals to plus y squared. Okay, so if you square both sides, you will get z squared equals to x squared plus y squared. So this is x squared plus y squared minus z equals 0. So remember, you have 2 squared and the right hand side is 0 and one of them is power 1. So this is just a cone. Okay, cone along z because the negative sign is on z. So if you draw 3D now, if you draw 3D, so let me draw the hemisphere first, which is radius 1, 1. Okay, see. Okay, then then the cone with the center, in the center also. Something I use different color so that you can see. Okay, inside the cone is just a circle. Okay, so you have to know chapter 1, traces, all sort of things. Okay, so the region bounded between these two curves will be this and this. Okay, I put in a different color. Yes, so this is the region. So this is just a, we can see ice cream cone. You can see this as a ice cream cone. Okay, so if I do separately, now we have a hemisphere. Okay, Z. Okay. Okay, now we have to know the limit of theta, the limit of phi, and limit of rho. Okay, so for sure limit of theta depend on xy, so this also can be found here. Sorry. This colored here, I think. Okay, so your theta should be, let's say I draw again. Theta will be from 0 to 2 pi, because it is here. And then your phi is now is from z-axis and up with the line cone. So if you see here, it is exactly on zy axis, it is halved. It is divided by 2. So I can say it's 0 to pi over 4. But there is another way. You can find it using the triangle. So let's say I take the axis, then we have a cone. Okay, and then we draw a line here. Okay, this is the phi. Okay, and then we already know the radius is 1. So here is 1, right? So this is 1. Here also 1. I think this is phi. Sorry, it's not theta. It's phi. And the whole thing also equals to 1 here. Oh, because here also equals to 1. X, Y, Z. Okay, this is 1. Also here is 1. Okay, so this is parallel to this. So tangent phi will be opposite of adjacent 1 over 1. So your phi will be arctangent 1, which is 45 degrees. 45 degrees is pi over 4 radian. Okay, and then the rho from 0 to 1. Okay, so now you can integrate. Now you can integrate. You can integrate g e to the power of negative x squared plus y squared plus z squared, the whole thing cube. dv will be, okay, three things, then 3 integral e to power of square root p rho squared. Remember, x squared plus y squared plus z squared is rho squared. So square root of rho squared will be rho cube. Then remember, your dv will be rho squared sine phi d rho d phi d theta. Okay, keep writing, then you can remember. So your rho is from 0 to 1, your phi is 0 to exactly pi over 4, and your theta is from 0 to 2 pi. Okay, so now you already convert into spherical coordinate, you can integrate. Okay, so you can integrate. So if you integrate this, you will get this, you will get 0.3355 pi. Okay. Pi. 0.3355 pi. Okay. Then application of spherical, that is volume. So for volume, fxy is equals to f function of rho phi and theta will be equals to 1. So thus your triple integral under g will be 1 dv, that is volume. So your dv is rho square sine phi d rho d phi d theta. So don't change the order. Okay, then your volume, full volume, will be integration under g rho squared sine phi d rho d phi d theta. Okay, question 2a. Question 2a, evaluate the integral by changing the coordinate to spherical coordinate. So they give you a coordinate -2 to 2, -4 minus x squared to 4 minus square root 4 minus x squared, positive square root, and then square root of x squared plus y squared to square root 8 minus x squared minus y squared, x squared plus y squared plus z squared dx dz dy dx. So they ask you to change in a spherical coordinate. So first you have to see the bound. Your x is between -2 to 2. Your y is in between negative square root 4 minus x squared to 4 minus x squared. And then your z is in between square root x squared plus y squared to 8 minus x squared minus y squared. Okay. So your y is actually plus minus square root 4 minus x squared. If you square both sides, you'll get x squared plus y squared equals to 4. So this is nothing but a circle with radius 2, which is project to z, and it is an cylinder. Okay, it is a cylinder with radius 2. The next is just a cylinder, okay, with radius 2. Okay, next for z. For z equals to square root square plus y squared. So this is a cone. It's a cone. along Z. Okay. Positive cone along Z. Then we have another one, upper bound is Z equals to square root 8 minus x squared minus y squared. So if you square both sides, you will get squared plus y squared z squared equals to square root of 8 squared, right? Okay, so this is a sphere with radius. With radius is square root 8. Okay, this is positive z. So we just represent this as hemisphere. Half of sphere is hemisphere, positive z. Okay. So if we combine all of this region in 3D, you will get again we have we have cylinder with radius 2, right? Okay, this is y, x, z. Okay, radius 2. Okay, radius 2. Let's say I put one radius. Okay, yes. Okay. Then we have cone. See the cone. Okay. Okay, we have a cone. Then we have hemisphere with radius square root 8. So square root 8 is 4 times 2, which is 2 square root 2. So 2 square root 2 will be bigger than 2. So somehow I just put here, then I extend this lines here. Okay, so it is bigger than, should be is bigger than. Okay, yeah, it should be bigger. Okay. 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 So if you look, you put your eyes here. If you look from above, you see it is a circle. Okay. We just choose the bounded part. This. Okay. So circle with radius 2. Okay. So from here, the upper part will be square root 4 minus x squared. The lower part will be negative 4 minus x squared. Okay, so then because we consider the whole circle, so from here your theta from x, this is x and y, x to here, so your theta limit will be 0 to 2 pi. Okay, your phi, so your phi here is from z axis to the sukun. So again, your phi is 0 to pi over 4. Okay, and then your rho is from 0 to square root 8. Okay, which is 2 square root 2. So now you can complete your integration. Zero to 2 square root 2. Here is, I think, rho square. So this is rho square, another rho square, sine phi d rho d phi, 0 to pi over 4, and d theta is from 0 to 2 pi. Okay, so if you integrate this, you will get 221.2 pi. Okay. So question 2B and C will be your homework. Okay. Okay. Also the final 2018-2019 semester 2 question 2C. Okay, you can check. I have an answer. You can check for me. Okay. See you again. So next topic will be on the application of triple integral, that is mass. That are mass, moment of mass, center of mass, centroid, and moment of inertia. Okay, bye.